All right, let's finish this up. So we got the top, we got the bottom. That's 50 pi altogether. We're just going to write in terms of pi for right now, all right? See how it goes. Because this book, they don't necessarily always have you put your answer like as a decimal. They're okay if it's in terms of pi and it all works out. They're okay with just leaving your answer in terms of pi. Ryan, you getting all this? So now what we want to do, Ryan? Can't happen. So let's take a look. Now I want to find the lateral surface area. So what I'm going to do is I'm going to write down lateral surface area. We'll just write it LSA. All right. The lateral surface area is equal to the what? Look in your notes. Tell me what it's equal to. I erased it up here. It's the something. What's the little phrase that I said the lateral surface area was equal to? Right. It's the perimeter of the base. I'll just put P for perimeter of the base times what? Times the height. All right, so let's do this. Now we've got to find the perimeter. We can call the top or the bottom the base because they're both exactly the same. So the perimeter, which is basically, it's a circle. So what's the perimeter of a circle? Give me the word. We said it earlier. It's the circumference, right? So let's find the circumference of this circle. Do you remember the formula for circumference of a circle? 2 pi r. Good. So 2 pi r times h. So look, instead of memorizing 2 pi r h, let's just remember the lateral surface area is the perimeter of the base times the height. You're like, oh, it'd be easier just memorizing 2 pi r h. But the thing is, we're going to use this for a lot of different figures, not just for a cylinder, a circular cylinder like this. We're going to use this perimeter of the base times the height for all kinds of different things. So we're not going to have to learn a million different formulas for every single different type of figure that we're going to do. We learn just one general thing. So the lateral surface area is the perimeter of the base times the height. All right, so let's do this. The perimeter of the base is 2 pi r. So let's put some numbers in. 2 pi r, which is 5. H is what? 12. All right, we can do this, can't we? 2 times 5 is 10 times 12 is 120 what? Pi. So look what we have. I've got 50 pi for the top and the bottom. I've got 120 pi for the sides, or this, right? That's what you just found, isn't it? You found the area of all the sides of this thing. If you took that Pringles can, cut it, sliced it right down the middle, and opened it up, you would get this thing. That's the 120 pi. So now, what do you do with that 50 and that 120? That's it. Multiply, is that what you said? You're not going to multiply it. You're just going to add them together. Okay, you're not going to multiply them because look what we did. We found this. We got the top, we got the bottom, and you don't multiply them together, you just add them all up. Because that's, you got top, you add it to the bottom, add it to the sides, and you've got everything. So what's 50 pi plus 120 pi? That's it, 170 pi. Now if that really bothers you, having pi as part of your answer, you could always throw that into a calculator now, couldn't you? But I think it's easier working with pi. I mean, we did all that in our head. Did I need a calculator one time for any of this? Nope. So, at the end, if you wanted to, you could go ahead and put times 3.14 and get whatever that is, and that would be fine. All right, but this book's pretty good about letting you leave your answers in terms of pi. In fact, if you look in the back on the odd problems, you may see it. You may have typed it in, 3.14, but it may be written like this, and you just have to be able to just differentiate between if you got it right or if you got it wrong. Now, I'm not going to draw all these things, but look at the very bottom of page 16. Do you see that? They got all these different pictures. They have a right oval cylinder. This right here, I'll give you the name for this. This was a right. Now, why is it right? Because look, the height and the base, right? If the base went around like that, do you see that? They're perpendicular. So we call that a right. What is the base of this? It's not an oval. It kind of looks like an oval here, but I just did that because it's on two-dimensional. But technically, what is it? It's a what? It's a circle, isn't it? So it's a right circular what? Cylinder. Good. That's why. All right, so that's what the name of that thing is right here. But if you look at the bottom of page 16, they give different ones. Now, there is a right circular cylinder. It's the second one in. Look at the first one, though. It's a right oval cylinder. Now, that'd be a little tougher because we don't really know how to find the area of an oval, do we? But if they told you what the area of the oval was, you could still do the same thing. Look at the next one, a right triangular cylinder. Can you find the area of the base of a triangle, if it's a triangle? Sure, just 1/2 base times height. Okay, you with me on that? So as long as you can find the area of the bases All you have to do is be able to find the area of the base and then multiply it by the height, right? Actually, I should say this. Find the area of the base to find that area, and then you'll be able to find the perimeter of it. If you can find the perimeter of it and then multiply it by the height, then you got the surface area, the total surface area. Sometimes the bottom is a triangle, sometimes it's a rectangle. See that one that's next to last? Or are you looking at your book? Look in your book. Page 16 at the bottom. See the next to last one? All right, it's a rectangular cylinder. Look at the bottom. Look at the base of it. It's a rectangle. Basically, that's just a regular box, isn't it? If I took a box, the bottom of it is a rectangle, and it just goes straight up and down. So you find the area the same way. Now look at that crazy. They just call it a right cylinder because that doesn't have a specific name. That's a crazy shape. But sometimes they'll tell you what the area of the base is. All right, they'll tell you the area of the base, or they'll tell you this circumference or the perimeter of the base if they're real crazy shapes like that. But they'll give you plenty of information to be able to figure out what the areas are. All right. Look at, let's do this real quick. These are all right. Do you see that? Right, circular, or whatever the situation is. But they're not always going to be right. They're not always going to go straight up and down. What if I just happen to have one drawn here, right? Yeah. Oh, there it is. Okay, just happen to have one drawn. And let's see what I want to do here. They call this an oblique circular cylinder. It's kind of slanted. They call it oblique. You ever, I don't know, you ever type stuff up and you see all the fonts and stuff? Sometimes it says italics, but anybody ever see one where the font says oblique? Like on InDesign, what we use for yearbook, it says oblique instead of italicized. You know what italics does? It basically takes the letters and kind of slants them. Okay, that's what the word oblique means. Okay, so oblique means it's just being slanted. Actually, we're not going to talk about an oblique when it comes to surface area. But what do you think the next thing is going to be? When you're a kid and you learn about area and stuff, what was always the next thing after area that you learned? Do you remember? Well, you probably learned perimeter first, okay, then you did area, and then you went to, think of three-dimensional. Think of three-dimensional objects and inside, okay, like you're filling it up. What is it? Yeah, volume, that's right, okay, the volume of an object, and that's what we're going to talk about tomorrow, okay? So we'll leave that for tomorrow. So we talked about area, tomorrow we're going to talk about volume, and it's very similar to what we're doing today, all right? Now here's what I want you to do, because I want you to go through there. There's a couple problems on here that you should be able to do now that we just talked about. So on problem set 2, all right? So I want you to start working on some of these problems. It might be another day or two before we finish lesson 2, and then I'm going to assign lesson 2 in one night. I'm going to collect it the very next day. So you don't want to wait and do 30 problems that night, do you? So try to get as many done as you possibly can, so when I say, okay, tomorrow it's due, you don't have to do all 30 of them. All right, so do as many as you possibly can and give some effort and give some, really try. All right.